Now we're going to talk about the midpoint approximation. We've already done left and right. So now the midpoint should be the average of the left and the right. So we're going to show you how to do that. Instead of using the left-hand side or the right-hand side, we're going to use the midpoint. So if you take a look at this curve right here, when we go to, if we do 3 equal intervals, the height of our rectangle is going to be the middle height of that interval. Okay? Let me straight here. All right, so it says approximate the area under the curve. And again, you don't need to know what this curve looks like. You can just make up some random curve. A little bit here. If you have no idea, it's not going to make a difference. But I know it's a parabola that opens down, so I'm just going to do some random shape like this. Again, it doesn't, you could draw a straight line. It really doesn't matter because you're not getting the y values from the graph, you're getting it from the equation. So let's see, we're going from -1 to 3. So let's figure out where that's going to start. If I'm going from -1 to 3, that's the opposite of a -1 squared plus 2 times -1 plus 11. That gives you 8. So this point that we're going to start at is actually -1 positive 8. And we're going to go to x equals 3. So it's the opposite of 3 squared plus 2 times 3 plus 11. And that also gives you 8. Okay, so we actually do have it's going to be the same y values. So we're going from -1 to 8 and 3 to 8. Okay. So if we look at equally dividing that up from a -1 to a positive 3, it says use 4 midpoint rectangles. So we have 4 rectangles. So if we cut it in half, that would be 2 rectangles. Cut that in half, cut that in half, that would be 4 rectangles. So if we look at it that way, the middle of -1 and 3 is 1. The middle of -1 and 1 is 0. The middle of 1 and 3 is 2. But it's not always going to be that easy. So we always have to remember the formula to find the difference in our x. Like what's the width? So again, it's your b minus your a. So that's 3 minus a -1 divided by how many rectangles you want, which is 4. So by using a little bit of common sense on how to divide them up equally, we came up with intervals that are 1. Using this formula, we came up with intervals that are 1. Okay, so the width of each of your rectangles, let me use a different color here. The width of each of your rectangles are going to be 1. So I know that, whoops, turn this sideways. This is going to be a rectangle. Sorry, I'm going to turn it sideways just because it's easier for me to draw a straight line. There will be another rectangle, another rectangle. So 1, 2, 3, 4 rectangles. The width is 1. Okay, the height or base times height, however you want to look at it, is going to be halfway in between. So this is the height of the rectangle we're going to use. So this is the height of the rectangle. There's our first rectangle. So in between, again, the midpoint, halfway in between, this is the height of our rectangle. So there's rectangle number 2, this right here, rectangle number 3, and this is the height. So there's rectangle number 4. Okay? So we need to figure out these y values. Well, what are the x values for this one? This is a negative 1/2. This one is a positive 1/2. This one right here is 1.5. We're halfway in between. That's why it's called the midpoint. And this one right here is 2.5. Now for this one, we will use a calculator, and for sake of time, I'll go ahead and I'll tell you what it is, but I need to find out these y values. 1, 2, 3, 4 y values. So I'm just going to create a table here using my midpoint. I'll just call it x sub n for the x value midpoint. Negative 1/2, positive 1/2. We can do 3/2 or 1.5 or 5/2 or 2.5, however you want to do it. Plug those into the equation here. Again, graphing calculator is fine. I would not expect you to do that without a calculator. So plug that in to find the actual y value. You're going to get 9.75, 11.75, another 11.75, and 9.75. So that would make sense. My graph doesn't look like that, but again, it doesn't matter how I sketched it because I'm getting the actual y values from the equation. Okay, so these are my y values. These are my widths. Okay, so the area under the curve. The estimate of the area under the curve using a midpoint approximation is approximately equal to, my base are all the same. So I'm going to shorten this up. Instead of doing 4 different ones, I mean, I could, I suppose. Base times height. I'll just do 4 different ones. Base times height plus base times height plus base times height. Or you could just do 2 of these and 2 of these. So on a calculator, that's going to total approximately 43. So very similar to the left and the right, but you use the midpoint height instead of the right and the left height. Okay. All right, example number 2. Different equation, area under the curve using 4 midpoint rectangles. Again, this is a quadratic, doesn't really matter. Let's just figure out where we're going to start. When you plug in the -1 squared minus 2 times -1 plus 3, that's going to give you a y value of 6. So I know, let's see, I'm going to start here. I know I'm going to be at -1. I'm going to start at 6. 1, 2, 3, 4, 5, 6. Close enough. -1, 6 is where it's going to start. And I'm going to stop at 7. Let's see, 7 squared minus 2 times 7 plus 3. That's going to total 38. So all the way down here is going to be, let's do 0, 1, 2, 3, 4, 5, 6, 7, 38. way up here. Let's put it way up here. So again, you can draw a straight line, you can draw a squiggly line, it doesn't matter. It's going to be some type of parabola. I don't know where again, just connect it with some kind of curve. The shape of the curve is irrelevant. Okay. So for midpoint rectangles, this is 1, 2, 3, 4, 5, 6, 7, 8. So obviously we're not going to go by ones. Would it make sense to go by twos? But again, there's a formula for that. Your delta x is b minus a divided by the number of rectangles you want. That's the width. So, again, let me use a different color so we can see. The rectangles, turn it sideways here. We're going to do a width of 2. So that's every 2 is going to be a new rectangle. Draw a straight line if I can. No, that's not good. Boy, I was really off, wasn't I? Make that a little bit bigger. Let's try again. 0, 1, 2, 3, 4, 5, 6, 7, 738. Again, let's go all the way up here. I don't know why I stopped there. Suppose I could have made my graph a little bit smaller. All right. So my width is 2. 1, 2, 3, 4 rectangles with the width of 2. I want to use my midpoint heights. So this is 0, 1, 2, 3, 4, 5, 6, and 7. The midpoint of this is here. Flat. The midpoint of this is here, here, and here. So that is how high I want my rectangles to go. So that's my height. There's my rectangle. This is my height. Here's my rectangle. This is the height I want. And one more. So 0, what's the height? Well, the height is the y value on that curve. So let's go ahead and let's make our table again. I'm using 0, 2, 4, and 6. And I'm plugging it into the original equation, the f of x, and I get 3, 3, 11, and I get 27. I already had those done. Obviously, that's why I got them done so fast. But you can check. Plug 4 into the original equation, and you'll get 11. So these are the heights of my rectangle. So the area, again, I can do base times height, base times height, base times height, but my base, they're all the same. So I only need to write that down once. I have 4 rectangles. The base is 2. The first one has a height of 3. The next one has a height of 3, then 11, then 27. So my approximate area, 2 times all of that is 88. Okay. Now again, I said the midpoint approximation is the average of the upper and the lower limits. It's more accurate than doing the left and right endpoint, but left and right endpoint is something that they ask more than midpoint. I'm like, well, why is that? What, it's more accurate? I don't know. They just like left and right more than they like midpoint. What else was I going to say? And you also don't know whether it's an underestimate or an overestimate from the midpoint. You only know that from the left and from the right. Okay? All right, so moving on, there's something called the trapezoidal rule. All of this, and so I'm going to show you where all of this comes from. It is making trapezoids. So let's review what you're supposed to know from geometry. The area of a trapezoid is 1/2 the sum of the bases times the height. 1/2 the sum of the bases times the height gives you an area of a trapezoid. So if we were to draw trapezoids, this would be our height of our trapezoid. If we go back to here, our base here, we called that base and we called this height. That's of a rectangle. When you draw a trapezoid under your curve, this is going to be your height. And these two heights will be the two bases we're going to add together. Whoops, sorry. This will be the height of your trapezoid. And these two heights will be the bases we're going to add together. So let's see what that looks like. Okay. Again, we're going to start from a -3 to 2. So let me just draw a little graph over here. -3 to 2. Where's the middle of that? Does that come out nice and easy? Yeah, that's... No, there's no middle there. All right, let me just count by ones, just so I can divide it up a little bit evenly. -2, -1, 0, 1, and 2. So start the same way here. We've got this equation here, -3. This is the opposite of -3 squared, -2 times -3 plus 9. If you add that correctly, you will get 6. So -3, 1, 2, 3, 5, 6. We're just going to call that 6 right there. -3, 6. And we're going to end at 2. That's the opposite of 2 squared, minus 2 times 2 plus 9. What does that give us? 1. So 2, 1. Okay, I have some quadratic that opens down. Again, I don't know where. It really doesn't matter where. There's some curve. Now, we're going to use the trapezoidal rule, which means make trapezoids. 5 trapezoids. So hopefully 1, 2, 3, 4, 5, we have 5 equal increments here, which we do. So do the same thing. Whoops, I missed there. Same thing we did before. We have our widths, we have 5. 1, 2, 3, 4, 5. So our width here is 1. But remember, that's not our width. Let me draw in the trapezoids. I'm going to draw those in red. The trapezoid is just like this picture over here. So we're going to go from this point to this point to draw the trapezoid. And this is going to be the 2 bases, and this will be the height of the trapezoid. So again, if you turn it sideways, you might be able to see the trapezoid better. Okay? So the next trapezoid goes from y value to y value. And here's your second one. Same thing. Here's your third. 4th, and 5th. 5 trapezoids. So I'm just going to call this 1, 2, 3, 4, 5 for right now. So I'm going to do it the long way. Okay? I'm going to find the area of each one of those trapezoids. So area number 1. Area number 1, the area of a trapezoid, is 1/2 the sum of the two bases. Now again, these are your two bases. This is the trapezoid. These are bases. This is the height. 1/2 the sum of your two bases. Or 1/2 the height times your sum of your two bases. However you have it memorized. Our height is 1. The sum of the two bases. Well, we didn't figure out these y values yet. So I'm going to go ahead and do those for you. I plugged in -3 and I got 6. When you plug a -2 in, you should get 9. When you plug in a -1, you should get 10. When you plug in 0, you should get 9. When you plug 1 into the equation, again, we're trying to find the y value, you will get 6. And I already did this one. When I plugged in 2, I got 1. Now notice, this obviously is not 9 if this is 10, but it doesn't matter because we're not looking at this. We're not looking at the shape. We're just using these y values. So in this trapezoid, this base, the length of this base is 6. The length of this base is 9. So that's 6 plus 9. If we do area number 2, that's 1/2 the height of the trapezoid, which again is 1, times the sum of the two bases, which is 9 and 10. For area 3, 1/2 the height. Well, the height is all the same, times the sum of the two bases, which is 10. Let's see, 10 and, we're right here, 10 and 9. Area number 4, 1/2 the height of your trapezoid times the sum of your two bases, 9 plus 6. Now I'm not adding them together for a reason. I'll show you in a second. And then your last one, approximately equal to 1/2 the height times the sum of your two bases. So base plus base. So the height here, the y value here, I should say, is the length of your base. Again, if you want to turn your trapezoid sideways because it helps, we're adding the two bases together. So this is 6 and this is 1. So 6 plus 1. Okay, now we have to figure it all out and add them all together. So it would be nice if there was a shortcut, which there is. So if you can see the pattern, what I want you to realize is that you start with a 6, you end with a 1, but look in between. If this one has a 9, the next one has a 9, right? If this one has a 10, the next one has a 10. If this one has a 9, the next one has a 9. What else colors I've got here? If this one has a 6, this one has a 6. So we can use a shortened version, a shortened formula, which says the area of the area under the curve using the trapezoidal method is approximately equal to 1/2 1/2 the sum of the bases times the height. Well, 1/2 this height right here is 1, because each one of these has the same. And when I say height, again, it's the height of the trapezoid. That's your base. So 1/2 the height of your trapezoid times the sum of your bases. Well, we have a 6, we have 2 9s, we have 2 10s, we have another 2 9s, we have 2 6s, and a 1. 6 here, 1 here, 2 9s, 2 10s, 2 9s, 2 6s. Let's compare that. Zoom out a little bit here. Compare that to this formula right here. This right here is 1/2 times b minus a divided by n. One half b minus a divided by n. 2 minus a -3 divided by 5 trapezoids. That's this right here. This is your first y value, your 6. And you have 2 of your next ones, 2 of the 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 next ones, all the way till you get down to the end. So that's what all of this is. So that's what that formula means. So you can do 5 of them individually and add them together, or you can remember that this pattern exists. I don't care which way you do it. It doesn't really matter. Just know how to draw trapezoids and know the area of a trapezoid is 1/2 the height times the sum of the 2 bases. So if you were to add this together, and yes, this is a problem that they expect you to be able to do without a calculator. I'm sorry if that's blurry. That looks blurry to me. So you would have to do all of this without a calculator. Okay? All right, one more example here. Okay, I'd like for you to pause the video and see if you can do this one for yourself. I have a sketch here for you. I want to approximate this area. That's the sine graph. So the y values are the sine of pi over 4, the sine of pi over 2, the sine of 3 pi over 4, the sine of pi, and the sine of 0. So pause your video really quick and see if you can do that one. Hopefully you paused. The sine of 0. The sine of 0 is 0. The sine of pi over 4 is the square root of 2 over 2. The sine of pi over 2 is 1. The sine of 3 pi over 4, square root of 2 over 2. And the sine of pi is 0. So if we use the trapezoidal rule, the area approximation using trapezoidal rule is 1/2. We're going to do pi minus 0 divided by 4 trapezoids. We're going to start with our first y value, which is a 0. And then we have 2 of the next ones, plus 2 of the next y values, plus 2 of the next y values, and then 1 of the last y values. So I didn't have to make 4 trapezoids. Okay? So that is approximately equal to, let's see, that's pi over 8. And this is square root of 2, square root of 2, plus 2, 2, square roots of 2, plus 2. Okay? If you wanted to factor out the 2, that's 2 pi over 8, which is pi over 4. That's an exact answer. Okay. type this into your calculator, and the decimal will be 1.89611. I want you to try math 8. I'm sorry, math 9. Math 9 is antiderivatives. Area under the curve is integrals. This is what we approximated the area to be using the trapezoid. Math 9, you will take the integral from 0 to pi of sine of x dx and see what it says. This basically does an infinite number of rectangles underneath here. So this is calculating the area under the curve by doing an infinite number of rectangles. It should be very close to this. That is midpoints and trapezoids.